Hello everyone, welcome to Payment Tech Media. In this video, you are going to learn about number systems. What is number system? It is a system to express or write numbers in a specific format to make it simple and understandable. For example, using digits or other symbols to represent specific value. There are different types of number systems. The same sequence of digits and symbols in one number system may represent different value in different number system. For example, 23 decimal, it's different than 23 hexadecimal. We will talk about it more. Well, what is neat about these number systems is that we have place values, and by the use of these place values, we can quickly understand the value of that number. But first, let's talk about how number systems created. Let's say way back an early human wanted to keep the track of the number of his hunting throughout his life. And for every number of his hunting, he would use a sign or a symbol. Let's say he would put a line for each number of his hunting. And of course, when the number goes up, it would be very difficult to understand or be able to count. For example, let's say one day his friend asked him, "How many did you hunt so far?" And he would show all these lines. That would be pretty difficult to understand how many it is. And if they wanted to understand, they had to count, and it would be very difficult. They could also make mistake during counting these lines, and they couldn't quickly understand the numbers by looking at all these lines. It would be very difficult. Now, to solve this problem, human beings have invented number systems. And this is the reason why we see number system in our life. To be able to count the numbers as simple as possible, to be able to look at the number and be able to understand what is the value of that number. There are 4 basic number systems that are used in computer science, networking, and humans. And they are decimal numbers, binary numbers, octal, and hexadecimal. Next, we will take a closer look at each numbering systems. First, let's go ahead and take a look at decimal number systems. Looking at the word decimal, the prefix deci, which means 1/10, or when we say decade, which it corresponds to 10 years. Therefore, deci is associated with 10. So decimal number system is a base 10 system. It means that we have 10 different symbols in decimal systems, which they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a total of 10 different symbols, including 0. This numbering system is used by humans for everyday counting. For example, 357, what does it represent? Well, as you remember, earlier I mentioned what is neat about these number systems is that we have place values. Now let's go ahead and talk about these place values. So here all the way to the right, we have place value position at 0. And of course this is a decimal value, so the base is 10. So 10 to the power of 0, it's 1. This is the ones place. Now let's go ahead and move 1 place to the left. This is the place value position 1. Base is 10, decimal value. It's a base 10 system. 10 to the power of 1 is 10. So here, this place is the 10th place. Now let's go ahead and move 1 place to the left. And here, position 2. So 10 to the power of 2. This is 100. So here, this place is the 100th place. And now if we move 1 more place to the left, this is place value position 3. 10 to the power of 3 thousandths. So here is the 1000th place. Therefore, when we talk about 357, it basically means 3 times 100 plus 5 times 10 plus 7 times 1, which is 357. And also, as we can see, every time we moved to the left, it did multiply by 10. So 1 times 10 is 10. 10 times 10 is 100. And 100 times 10 is thousands, because decimal is base 10 system. Now let's take a look at binary number system. So when we hear binary, the prefix bi, what comes to our mind? I think of bicycles, so bi means 2. Therefore, binary number system is a base 2 system. We have only 2 symbols in binary, 0 and 1. The underlying mathematics and operations that computers perform are based on binary. All the circuits used to build a computer are using transistors, which they either result in an on or an off state. Therefore, binary system is used by computers or any type of digital circuits. For computers, 0 means off, the absence of electricity or current, and 1 means on, the presence of electricity or current. Do you remember in decimal system we talked about place values? Well, we have the similar place values here as well. But instead of these place values being in powers of 10, they are going to be in powers of 2, because binary is base 2 system. So let's create these place values for the binary. So here we do have the place value position at 0, and the base is 2 because of the binary system is a base 2 system. 2 to the power of 0, it's 1. Now if we move one place to the left, this is place value position 1. 2 to the power of 1 is 2. And let's continue moving to the left. So this one is place value position 2. 2 to the power of 2 is 4. Moving on one place to the left, this place value position is 3. 2 to the power of 3 is 8. And so on. If we move on to the left again, this is position 4. 2 to the power of 4 is 16. And if we continue moving one place to the left, as we can see here, this is place value position 5. 2 to the power of 5, 32. Place value position 6. 2 to the power of 6, 64. And place value position 7. 2 to the power of 7, 128. And so on. Here, this is one example of putting 8 place values. This is place value 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 7, total of 8 different place values. Yes, we could have 9, 10, 11, 12, 13, and so on. But in this example, let's just use 8 different place values. Now let's take a look at one binary number of, let's say, 1, 1, 0, 0, 1, 0, 1, 0. Here we do have 8 bits. Every binary digit is 1 bit. Some of them turned on, some of them being turned off. This binary number is equivalent of 202 in decimal number system. Let's see how. So here we have 1 times 128 plus 1 times 64 plus 0 times 32 and 0 times 16 1 times 8 0 times 4 1 times 2 and 0 times 1. So here we have 128 plus 64 plus 0 plus 0 plus 8 plus 0 plus 2 plus 0. Therefore, we just need to count the ones that are already turned on. And again, 1 means being on. In this case, 128 plus 64 plus 8 plus 2. And now if we add all the numbers, 128 plus 64, that's 192, plus 8, that's 200, plus 2, 202 in decimal value system. Therefore, binary number of 1100, 1010 is equivalent to 202 decimal number systems. Now let's take a look by using the calculator. So we want to make sure we change the view from standard view to the programmer view. And here, as we can see, we do have these options. So we want to make sure BIN is selected. So selecting BIN, and you probably noticed only 1 and 0 is available. Other numbers grayed out because in binary we have only 1 and 0. Okay, so let's put this binary number. We have 1 1 0 0 1 0 1 0. And as we can see here in decimal value, it gives us 202. So this binary number is just another representation of 202 decimal. And here, as you noticed, when we moved one place to the left, it did multiply by 2 because in binary system is a base 2 system. 1 times 2 equals 2. 2 times 2 equals 4. And 4 times 2 equals 8. 8 times 2, 16. 16 times 2, 32. And so on. So here, this was one example of binary number, and we did add the decimal values of the one that is already being turned on. In this case, 128 turned on, plus 64, plus 8, and plus 2. And it gives us a decimal value of 202. Now let's take a look at octal number system. Now looking at word octal or octal, what do we think of? I think of octagon, which is a polygon with 8 sides. Therefore, octal means 8. So octal number system is a base 8 system. So there are 8 symbols in octal system, which they are 0, 1, 2, 3, 4, 5, 6, and 7. So that's a total of 8 numbers including 0. Well, here we can see similar place values for octal number system as well. So instead of these place values being in powers of 10 or 2, they are going to be in powers of 8 because octal is base 8 system. So let's create these place values for octal. Here we have place value position 0, and in octal base is 8 because octal is base 8 system. So 8 to the power of 0, it's 1. Again, any number to the power of 0, it's 1. Now if we move one place to the left, this is place value position 1. 8 to the power of 1 is 8. And next place value position is 2. 8 to the power of 2 is 64. Let's move one more place to the left. This is place value position 3. 8 to the power of 3, it's 512. So here we have 1's place, 8th place, 64th place, and 512th place. And as we can see here, every time moving to the left, it multiplies by 8. So 1 times 8 equals 8. 8 times 8 equals 64. And 64 times 8 equals 512. Why multiplies by 8? Because octal is base 8 system, therefore it multiplies by 8. And here also we can see place value position, base is 8 to the place value position, and it gives us the actual decimal values for that place value position. So as we can see here, in octal, every time when we go to the left, we are multiplying it by 8 to get the next place value. So in octal, every time when we go to the left, we are multiplying it by 8 to get the next place value, as we can see here. Why 8? Because octal system is a base 8 system. And here we can see place value position 0, 1, 2, 3, and base is 8. And 8 to the power of 0, 1, 8 to the power of 1, 8, 8 to the power of 2, 64, 8 to the power of 3, 512. Now let's take a look at octal number of 577, which is equivalent of 383 in decimal number systems. Let's see how. Well, we can apply the same formula of the place values as we did earlier for the decimal and the binary. This means that we have 5 times 64 plus 7 times 8 plus 7 times 1, which is 320 plus 56 plus 7. That gives us 383 in decimal number system. Now let's see it in the calculator. So first, changing the standard view to the programmer view and then making sure octal is selected. And as you noticed, we have 0 to 7. In octal, we have 0 to 7. 8 and 9, it's grayed out. Okay, so let's put this octal number 577, right? 577. And it gives us a decimal of 383, as we can see here. And now let's take a look at hexadecimal number system. And now when we hear hexadecimal, what this prefix of hexa means. We can think of hexagon where we have 6 sides. So hexa means 6. And as we know already, the word decimal corresponds to 10. So 6 plus 10 equals 16. So hexadecimal number system is a base 16 system. So there are 16 symbols in hexadecimal system, which they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So that's a total of 16 numbers including 0. To keep the single digit symbol, we see the use of alphabet letter A to F. The letter A corresponds to 10, B 11, C 12, D 13, E 14, and F 15 in decimal numbering system. And here as well, we can see similar place values for hexadecimal number system as we saw earlier for other number systems. But instead of these place values being in powers of 10, 2, or 8, they are going to be in powers of 16 because hexadecimal is base 16 system. So let's create these places for the hexadecimal. So here this is place value position 0, base is 16. In hexadecimal, right? 16 to the power of 0, it's 1. Any number to the power of 0, it's 1. Then we can move one place to the left. This is place value position 1. 16 to the power of 1 is 16. And if we continue one more place to the left, this is place value position 2. 16 to the power of 2, which is 256. And this is place value position at 3. 16 to the power of 3, 4096. So in hexadecimal, as we can see here, every time when we go to the left, we are multiplying it by 16 to get the next place value. And again, why 16? Because hexadecimal is base 16 system. Now let's take a look at one hexadecimal number. Let's say 1A7. And by the way, sometimes in hexadecimal number systems, we might see 0x in front of hexadecimal number system. It's basically telling us the following number is hexadecimal. For example, if we have a hexadecimal of 23, we don't know if this is a decimal or hexadecimal. Therefore, by putting 0x 23, we know this is hexadecimal number, not a decimal. And as you noticed, I said 23 because this is not the same as 23 decimal. Now let's take a look at one hexadecimal number. Let's say 1A7, which is equivalent of 423 in decimal number system. Let's see how. So here we have 1A7. Well, we can apply the same formula of the place values as we did earlier for the decimal binary octal number system. This means that we have 1 times 256 plus a times 16 plus 7 times 1. So 1 times 256 is 256 plus a times 16. What is a? So here, as we can see, a is 10, right? So let's write 10 here times 16, which gives us 160 plus 7 times 1 is 7. And it gives us 423 in decimal number system. Now let's see it in calculator. So we want to make sure the standard view is the programmer view, and we want to make sure hex is selected. And you probably noticed here we have also A, B, C, D, E, F available as well. Okay, let's put 1, A, 7. And here we can see the decimal value of 423, as we can see here. Now when do we use hexadecimal number system? It is used in IP version 6, MAC addresses, or even in web development when we work with HTML or CSS. So as you can see here, as the value of the base goes up, we can have a larger number with less digits. In the next videos, we will see more examples of these number systems and how we can convert them from one number system to another. This was an overview of different number systems. Thank you so much for watching. If you have any question, you can leave it in the comment section. If you liked the video, please hit the thumbs up. And if you haven't subscribed to this channel, please subscribe for more tech videos like this. Thanks again. Have a good day.